One. What is up, everybody? Welcome to Data on Kubernetes live stream number 119, I believe. We're really getting up there in terms of the numbers. Always a pleasure to be here. Very excited about today's live stream. As usual, you know you're going to hear the news about KubeCon because we got our third co-located event in KubeCon coming up on May 16th. Was just talking to Shiv. Hope we can get him to submit a talk. Our CFP is very much alive and thriving, getting lots of good submissions. So if you want to give a talk, please check it out. Very clear guidelines, what we're looking for from a content perspective. We're hoping to have 2 tracks because we had so much content in the last one in October. We want to open up to have more options and more opportunities for different folks to speak. So definitely keep that in mind there. As usual, keep the conversations going in Slack. All right, we've got great speakers that are ready and willing to answer your questions. So get your questions out here in the YouTube chat, but also remember that we can continue the conversation in Slack. Plenty of live streams that are coming up. You can see all that in our meetup page. Also drop the link there just in case. And without further ado, I would like to invite our speaker today, Shiv, who has lots and lots of database experience on the vendor side, on the end user side. Shiv, can you just give us a brief summary of all the databases that you've worked on?
First of all, thank you so much for having me on this conference. It's been a great program what you guys drive. Connecting people, sharing knowledge, both are equally important for all of us to have access to the knowledge as well as staying relevant, right? So thank you so much for making this happen.
Our pleasure.
All right, so I'm an open source database systems guy for over 2 decades. So I focus across, so started with MySQL, ABs on microsystems, and then across transaction processing, open source database systems, including PostgreSQL and MariaDB. But over a period of time, what happened was that there's a transformation happened from a vendor-focused MySQL consultant to someone who is building an open source transaction processing system for web scale, addressing performance and reliability. So that became my role. So there was a transformation happens. The data identity have changed from being a transaction processing system, and eventually all these transaction processing systems data became the source, the fuel for analytics operations. So it's been last few years working from quite early days of ClickHouse, and I'm also the founder and principal of MinervaDB, and ClickHouse only managed support service provider for both on-premises and cloud called Data. Okay. So I'm the founder and principal of both of these companies. We serve approximately 500 customers worldwide. Some of the largest internet properties in different domains like fintech, fintech, ad tech, all those guys. Worked on multiple continents. Worked on all the 5 continents. Wow. Worked on 37 cities worldwide. So yeah. Wow. It's been a great journey, consulting and support and managed services across these database systems.
Good. With that in mind, I want to get into your presentation, but you've seen, obviously, you've got 2 decades of data experience. You've seen the evolution. As we're getting into this Kubernetes space, as vendors and end users are embracing the challenge of getting to this point, what's the vibe? What's the feeling that you're getting in terms of what's happening right now? Where do you think the major challenges are, and what might we be able to expect in the future?
The problems solved by data infrastructure owners, or like you can call them DBAs, or today you call them SREs, or data platform engineers. So eventually what each one of them are accountable is guaranteeing the most expensive asset of each corporation, which is a digital asset, which is data, optimal. Because today, if you look at the data is accessible on wearables, on smartphones, that's not something new. Like today we use more data-powered platforms compared to anything else for life and for the business. So compromise on performance is unacceptable. The volume of data growing is just beyond even the computation formulas we applied in the past. That means that the storage optimization is something which we need to seriously look out for. Data compression is something which also we need to discount as we are talking about machine generated data. Third is about how we create an ecosystem which is built for scale and reliable. So if you ask me what's going to be the challenge for a data platforms guy, be it for a transaction processing system or analytics or eventually consistent system, the challenge remains same, like because each one of these geeks are solving the challenges to make sure that the data infra is consistent in performance and reliability. Because if data infra goes down, that's a direct impact on the business. Like most of us, there is a power outage. It's acceptable. We are used to power outage. But then if any of the platforms which rides our life today, like for example, Google going down for or WhatsApp going down for 40-45 minutes means this is a serious problem. Then we need to look at what are the alternate ways to connect with the people whom we know. So the consumer facing internet companies, consumer facing applications today play a larger role. And these are all immensely powered by data, which could be like a transaction processing data or analytics data. But then these data plays a vital role. So we are accountable. When I say we, the data platform stakeholders are accountable to make sure they are available.
Very, very good. That being said, excellent answer. Excellent answer. I loved, and once again, we can't forget that, because we simply cannot forget about the most valuable asset that an organization has is the data. So this is something that has to be treated with a great deal of responsibility, which is also why we've seen, and it's understandable, we have to use empathy here, that a lot of organizations will be hesitant about their doubts regarding, should I be moving my data to Kubernetes? What are the risks? Because a general sort of idea is leave the data alone, don't touch it, leave it exactly where it is, and you won't have to worry. But then we have to consider, what are the advantages, the benefits, the positive things that can come out of this from a technological perspective, from a financial perspective, from a vendor lock-in perspective, to avoid that of moving stateful workloads onto Kubernetes. That being said, though, let's jump into your presentation. As usual, folks, keep the questions coming in the YouTube chat. We'll get to them accordingly, and you can start sharing your screen.
Right. So I believe you guys can see my screen
Looks
now.
great. Yeah.
So my talk today is about how do we troubleshoot ClickHouse for our production infrastructure operations, and what is a methodology and what is the process we follow to make sure that we are building we are building a process for seamless ClickHouse infrastructure operations. About me quick, I'm the founder and principal of MinervaDB, which is a consultative support and managed services provider for MySQL, MariaDB, and PostgreSQL, and also for Chista Data. So Chista Data is a new company. We are a 6-month-old company now. The company is a full-service ClickHouse infrastructure operations support provider, delivering both consultative support and managed services on premises as well on cloud. Chista Data is a funded company by Sequoia Capital, and we are making a direct impact on some of the largest healthcare as well the fintech companies globally. So what has been my technology focus? I've been an open source database systems guy. Started as a guy who worked on InnoDB, moved to MySQL, and over a period of time, my focus been like how I can build a fully optimal and reliable database infrastructure on open source data platform, database infrastructure stack. So today, I work on MySQL, MariaDB, PostgreSQL when it comes to open source transaction computing space, and also on ClickHouse when it comes to building systems for analytics, column style. So you can follow me on Twitter, and you can also write to me on either of these two emails. So when I talk about performance, right? Performance accelerates business. So when I talk to people of multiple professional interests, like be it a business owner or an engineer or an infrastructure operations guy, what is a simple term to define about performance engineering? So it's quite direct. It's about how much time an operation takes to complete. It's a response time. Complications can be like, I have a system which consumes, say, 99% of CPU, which extensively swapping out during the higher consumption of memory, and the disk I/O throughput is, say, 50,000 megabytes per second, or what will be that number? But that's irrelevant for a business owner, right? When I say business owner, it's not just limited to the functional business owner, which could be even someone who owned the technology infra. So keeping things simple always helps to troubleshoot, because the language of setting the performance operations is something we need to be very cautious about. Make it as simple as possible. So response time, and also understand how the system performs during the peak hours, about how the connections are handled. Are you looking at the response time limited to the time it takes for a process to complete, or you're also measuring from the state and the process begin, and if there are any wait events due to some planned or unplanned processes, or if there are any deadlocks. So if you put the more meaningful context to the performance engineering, it becomes quite direct. So when I capture the same thing on a diagram, it becomes even more direct, right? It's all about what is the MIPS, what's a number of millions of instructions processed or executed per second. Again, not to confuse. So more MIPS is definitely not meaning that you have a very high performance system operational, but technically, if you look at a cockpit view of a system, if you look at what you see on a system, it's like, hey, there's an application which could be SQL or NoSQL, which is evaluated with the corresponding compiler or optimizer, if there is anything, and which build the data access path, which is about, hey, which schema objects are accessed, which indexes are used, and what is going to be execution plan. That execution plan is the one which drives the application to the persistent data, or the data which is expected out of that query, which is expected of that program, right? And what as a performance engineer I look forward to is like, what is a response time for that single query took, and how much is that program efficient? Like how much it's how many number of rows scanned and what is processed. That's it. So effectively, if you see that, if I can find out a diagrammatic representation of each programs, each queries which are triggered on my ClickHouse, and find out how the program access the indexes available, and which partitions are accessed, if you have partitions, which schema objects are accountable to provide data, and what is the data access path, and what is the latency. That gives the context of what I'm talking to when it comes to performance engineering. But where does the performance troubleshooting comes? How it begins? This is a very interesting question, right? There are two ways I get to work with people. There are times I get to work with people, they just call me, like a time of the day or even the night. Hey, Shiv, we're finding a problem with the performance. Can you guys jump in? Two is the guys like who already contracted me, where I take an initiative to go and talk to them about performance and why performance is is a business accelerator. It's not just a feature, right? When you say that, hey, I have built a system which is built for performance, and that's a great feature. Like I've seen many times application architects, the business owners say, something, I have a high performance fintech platform. Good. This is something which you expect, right? That's a business accelerator. Accelerator for who? Customers who are spending time on top of your application. Like for example, I use like say Uber. I use several of apps, like each one of you in my phone. And for me, like when I go for request, when I go for submission of a request, I'm expecting an optimal response time. So that means there is a customer investment happening, right? We all trade on time. Then there's a technology infrastructure, right? The systems which are not built for performance are expensive for the business. Means like none of the companies worldwide say that, something, I don't worry about performance. This is how it works. No, every company invests a lot for infrastructure, and infrastructure is also equally important for performance. But then if you're going to scale performance with faster computing resources, that's not the way to scale. So that means that whenever you go for capacity improvement, enhancement, that means that there's a cost impact to that, and that impacts directly on the margin. So that means that there is a business impact and there's a technology infra impact. And technology automation process failure. There's something like, should I really worry about tuning my ClickHouse, my application? I would say like, this is something like when you are not spending the effort, or when you're not spending for an initiative which is about detailed performance diagnostics of your ClickHouse infrastructure, that means that you end up in compromising. Hey, something, I have 10 query requests happening during peak hours. After 3 are very important, 7 are not so important. When I see that there's a performance compromise happening, maybe 5 out of those 10, I say like, something, I can do it on alternate ways. That means that I am again handicapping. Like I'm again, like I'm trying to deflate the potential of the application, what it's built for. I'm trying to do that as either as a manual process, or even when I say something, we're not going to do that. So all this will lead to what? Like it's all about unhappiness, right? Like your customers are not happy, your suppliers are not happy, your partners are not happy, the whole ecosystem is not happy. Continue that, you will end up in losses. Continue that, you go for layoff. Continue that, you go for a shutdown. Eventually, this all impact directly and indirectly on the economy. So when you say that performance is something which has a broader influence and impact on our data normie business, like each and every company today is a data economy, right? Take all the business which you're talking about, right? Which drives us, right, from Google to even a grocery store who provides me groceries, right? Everything is data-driven economy. So any impact impacts each one of us, and that is not something which we definitely expect. Now, understanding where does ClickHouse come from and why do we need a new data store, right? One, ClickHouse is not something which supplement traditional transaction processing system. If you're using MySQL, PostgreSQL, MariaDB for your transaction processing system, or be any other transaction processing system, is ClickHouse is something you're not you're going to use it to supplement with? Answer is no. No, ClickHouse is not for that. ClickHouse is built for analytics, open source column store built for analytics, which is built for performance because the persistent data on ClickHouse is sorted by primary key. So that means that every of your sort search intensive operations, so if you look at each of the application we use are majorly aggregators today, like even Uber or my grocery store, or be it anything, right? Even and any of those are predominantly aggregators. A lot of sort search intensive queries happens there. Not every part of them will fit on a column store, but a lot of parts can fit pretty well on column store. So ClickHouse is that, which is an open source OLAP column store capable of using all your investments on your new high performance multi-core machines, and that completely distributed SQL compliant. So this is the, this story looks good, right? I have an open source database system which is capable of massively parallel processing and built for distributed OLAP queries. So what is a problem we are trying to solve? What are the challenges? OLAP systems really grow big. So if somebody asks me like one line of difference between a transaction processing system and OLAP system, transaction processing system, the problem we're trying to solve most often is not storage. They grow big, but then not really as storage. We in transaction processing system, we solve about how we can make transactions are optimal. They're not failing. Whereas in OLAP, we are looking at like, hey, something, a crazy amount of data. Like today, I have personally worked with several wearable companies, which are like multi-petabyte of data. And when more data is a more problem for us. One is a performance. Two is, again, the consistency of performance. Three is about capacity planning sizing. Four is about the reliability. Five is about getting all these things continuous at a scale. So also the cost of storage, right? We need to look at something, a column store, which is capable of compressing the data more efficiently. And ClickHouse has a specialized codecs for that, which makes sure that your compaction factor, your compression factor for your data is optimal. So when you look at it at a bigger scale, troubleshooting the ClickHouse performance is again a specialized skill, right? This is not a generic skill. Like this is something like you need to have a deeper understanding about how all these things work on production. So this is not a generic skill. This is about understanding how all these things work in tandem. Okay. What is a methodology? How do you start performance troubleshooting? I get like, I tell you, the complexity of performance troubleshooting is not just limited to the volume of data, the traffic, but then there are internal challenges. Today, the amount of data accessible for me to troubleshoot is also very high. Something which is more is also not good. Like today, 10 years back when I used to be a performance engineer, like I was not having access to so much of data. That means like, hey, I want to troubleshoot a performance. I have a limited access to data. Like I take the query log and look at like, hey, where is application spending more time? Which are those top 10 SQLs which I need to have an immediate attention. That is not the case today. Today, I have time series performance monitoring system. I have dedicated observability and infrastructure. A lot of Linux tools which are capable of troubleshooting database performance. A lot of data dictionary tables, system tables, which provides me a lot of information. So there is a tsunami of information there. Now, for me, the challenge is like, do I need all the data? That's a new performance bottleneck to solve. Then what will I pick? Because I don't need every data available. I need to choose the data source carefully. Then querying everything is an extra load to the system. If somebody tells me like, hey, Shiv, can you troubleshoot the system? And if I look around for say 100 tables and run another 50 scripts outside database systems and say like, something, I'm collecting data, but what are you collecting? What do you really need? Do you need a lot of data? No, because when you're doing troubleshooting performance, this is a very expensive engagement. Because expensive from the sense like when you're troubleshooting performance reactively, that means that business is already impacted. So you can't say like, I'm going to take a month to troubleshoot performance. So understand what is the unit of performance. Like I said, where application is spending time and which processes are the epicenter of that. What is the throughput for an application, and what are you using, right? Because we need tools, we need data to troubleshoot, because it's all going to be completely evidence-based. So choose what you need and set the goal clear so that you are not getting everything. I start with simple things, right? I don't like to complicate things. Like I look at like, hey, where do I start with, right? I want to see that at a infra, like what is happening to the system, like who are the biggest consumers of the resources available, So I use basic, simple Linux, or if I'm on a FreeBSD system. So I work both on Linux and FreeBSD. So I look at the very simple tools which are available. I don't need to have an extra, privileges to install those tools to start my work. So what are those 6 tools which I use when I start my performance audit? I want to see where are those top processes coming from, and by latency, and detailed report on how those individual processes are consuming resources. And I use VMstat just to find like how is swapping paging happening, and broadly understand like how is the disk IO distribution looking like. Of course, I look at this network socket performance when you are on a cross geographically distributed data infrastructure. So this is about measure the infrastructure. How is it consuming system? So technically, if you see a CPU performance, what we say is measured by cycles per instruction, just like how the CPU performs for each of the processes, active and idle, and that's it. And so in this slide, if you really look at like what I'm really looking forward to is like who are the top consumers of CPU and what are they executing? Simple. This narrow downs me. So as early as possible, you should narrow down on your performance troubleshooting. Going continuously broad, like hunting for as much data as possible is good, but then it's also about money, right? It's about time. When I say time, money are proportionate to each other, right? So you say like, hey, I want to find out where is epicenter. Not necessarily every time there will be a ClickHouse is a problem. So I want to first make sure that there is a ClickHouse. Which is the root cause of your system's resource hogging. And so this is so I use SAR on, so as I said, right, I get to work on both FreeBSD and Linux, and BSD SAR, I don't configure, over configure. I just configure only when I need it. But when I'm doing a performance diagnostics, I configure my SAR configuration file to collect CPU disk and swapping data. I mean, I take most of it. NFS, I don't use it often, so I don't use it. But then yes, I take how the infra is consumed. And then it's like, so where do I measure this, right? The goal setting is very important. Let's say that if I don't know what is an available memory, free memory on a system, and then I can't plan for the caching. Like as much of data we can have the memory is good because your reads and writes will be faster. Can I have entire data on reads and writes on memory? Answer is yes, if I'm on an OLTP on a transaction processing system. Like I said, like when I have a system running on say 700 terabytes, 800 terabytes, a petabyte, or multi-petabyte, right? Now, when I say that I won't have everything on the RAM, that means like it's going to be a seriously expensive system. So why do I need to know like what could be the amount of data each query is getting to the memory? Do we have that capacity? And what is the load on the system? Like how many such queries are hitting my ClickHouse instance during a peak hours? And what could be the maximum data a sort select can happen on ClickHouse, and what could be my swapping? So this is to understand about what is the limitations of my system. So if I can understand what is the limitation, I can set the expectations clear. That's the only thing. So the basic point when you're looking at do I have a very standard? This is the standard method of performance troubleshooting. Not really, because when it comes to troubleshooting infra like like a ClickHouse, right? Like I keep saying, right? We're very large database infrastructure where we continuously look forward to how we can distribute the query load, how I can use all the processes available, how I can distribute the SQL operations. That means like how I can use the most efficient way of partitioning the schema objects, how I can make the query operations parallel. That means that I need to know about what is the throughput capability of my storage infrastructure. So that helps me to distribute the read-write operations, meaning that there is no single storage mount or infra is accountable for the complete performance or the load of the system. So when I'm working on performance audit in ClickHouse, I'm looking at a very large production infra with loads of data on it, and I can clearly understand that the challenge is like there will be two factors. One is like a serious performance issue when it comes to writes, and more serious of that is like, hey, we are reading a lot. Our queries are quite complex. Go for a wider data access patterns. So naturally, there is a performance bottleneck related to the data seek and data processing and even the limitations of the storage as well as the RAM. So if you have a clarity on how your systems are performing from an infra perspective, that helps me to be more honest to my audit report. Now, once I have identified, hey, look, this is the infrastructure which I have hosted my ClickHouse. Why I look to trace creating a system which is traceable. There's like I said, there are several ways to look at the performance, right? Like if you look at like I didn't go to several complicated tools. All I used was like very basic direct ones, which I want to understand like how systems behaves, what are the capability of the system. The next my step itself is like tracing the application. Trace is one direct method to get the data access path of an application. End of the day, every query which happens on a ClickHouse is building a data access path, which is nothing but how the SQL origins, which are the table objects accessed, which are those columns, and how the index how the index access model looks like, and internally how the optimizer is taking all these things. So in this case, I don't want to talk about optimizer in ClickHouse, that is irrelevant. Then here I'm talking about like how the execution plan look like, and how we can make an efficient data access path, and know both usual and unusual incidents happening. Like for example, I'll have usual expected is like, hey, something. I have a schema object with the indexes on few of these columns, and these columns are criteria of my select programs, and they are used. That's good, and still there is a performance issue. Then I need to look at like, hey, why there is a performance issue after having an index? That is expected problem. Unexpected is like I have an index. That index is not used. It's even a bigger performance problem for me to solve. One, I have to see like why there's index usage, why the ClickHouse is not using the index. Is the construct of the SQL is a bottleneck. Two is that what else could be the problem? Then how the system components are consumed by the application. This is something which is very important. And also I have to record both successful and unsuccessful events happening on the infrastructure. Let's see that you have a continuously have wrong queries which are referring to wrong schema objects, and that's happening continuously, and that's creating an error. But for end business owner, it's like, something, my ClickHouse is always busy. It's not doing anything relevant, but then it's always busy. So I need to record everything, both successful and unsuccessful incidents, and how ClickHouse is internally handling it as a process. But like every request is coming as an independent thread for ClickHouse. So we need to look at like what is the thread performance latency and thread throughput. So if I put it like, when I trace an infrastructure, a ClickHouse infrastructure, I look forward to one, performance. Two is like am I doing everything as expected? That means it's a sanity testing of an application. 3 is like how the performance is measured from the process, from the thread operations level to the ClickHouse server instance, and eventually like how to have a cost efficient capacity planning sizing effort. You hear me saying this often, right? Capacity planning sizing. Yes, like, because as I say, like when you're building a very large database infrastructure on a all app store, right? Whenever there's a problem, like, hey, something, there's a serious performance issue. We'll have a week's time to solve this. If you're not going to fix on this, then we're going to buy a faster process, because business cannot tolerate for the loss of the business, right? So, like, end of the day, like, can we solve it? If you're not going to solve it, we're going to invest on machines. So we need to be also conservative, like how we are going to do the sizing of the infrastructure. Like I said, there are several tools, right? Today, if you see that, I have not spoken about this tool 10 years back, eBPF. I would have definitely not spoken this tracing using multiple Linux tools. If I'm talking about purely troubleshooting a performance infra, if it was several years back. Today, I have access to several tools. Thanks for some of the fantastic performance engineers today we are around. eBPF, all of us read book of Brendan Gregg. He makes a lot of effort to make our life awesome. What's it? So this is nothing but a packet filter, which is built traditionally for filtering the network packets on how the system resources are used. Eventually, like, if you really look at like what BPF was built for, was like he decode the packets and annotate them in a meaningful performance language, performance engineer language, authored by Alexei and eventually built a lot by the community. So technically, what happens is like eBPF accesses the data structures of the underlying Linux kernel, and using multiple front ends. I mean, you can use PCC or BPF or perf. You can use multiple front end on eBPF, and you can record the performance from multiple metrics, performance engineering metrics, like right from the CPU usage to memory, from disk ops, from an application point of view, from a database instance point of view. It's very extensive, right? Again, how do you use it is again left to you. You can spend months together on a database on a ClickHouse infra to use eBPF to create a lot of data. Then consolidating it is an even bigger problem to solve. If you're making a direct impact, you need to know like how you're going to use it. So what I do is like when I'm using eBPF, my purpose of usage is very, very direct. I want to find out like how when I use top, I get the processes which are expensive, but when I'm using a BCC tool like EXE-Snoop or OpenSnoop or biolatency, each of them get into deeper level of understanding about not just the metadata of the performance bottleneck, but then the detailed story, the actual data, like which is that SQL, which is that application, which is that thread, which is causing my average response time of my application to spike, and why am I using more of disk operations than it is expected. Like for example, when I'm using BioSnoop, what I'm doing is like I'm measuring the disk ops, including how the queuing happening from both on a read and write, making a latency to the operations, to the query ops. So three things which I look forward when I'm working on using BPF. One is about the thread handling efficiency queries, thread handling thread handling processes. And 2 is about the disk ops, which is about like how these threads are creating intensity on the disk op. The third one is about the actual code, the application, which could be SQL, which could be a raw application. But then I want to know that what is their data access model look like, and how long these threads are operational. Like, are they staying idle, or is there a way they gracefully disconnect and again using some thread caching mechanism so that they can come back faster. So DTrace. So how do I see a differentiation? So both DTrace and BPF, I functionally they solve the same requirement, right? When I'm using BPF for me is a new avatar of DTrace on Linux. Is BPF for me. DTrace I use them when I'm troubleshooting on FreeBSD infrastructure. I use DTrace to measure how the CPU usage and distribution look like. And say, if you look at the metrics is not changing. Now, if you see that the metrics, what I'm capturing on using BPF and DTrace is same. It's only about the tool which I use on different distribution of the platform. I use DTrace on FreeBSD, I use BPF on Linux. So what is something which really attracts me using DTrace? Like most of us, like I get 3 things. Like as I said in the previous one, right? I can profile the entire systems usage, resource usage patterns against the applications, which are the consumers of the resources. 2 is about the detailed annotation of the system's infrastructure operations on both during peak and off-peak hours. And what are how my available RAM is used by the processes with PLOGstat. So if here I use only two one-liner commands, right? Again, this can be super big. Then I use I want to see how much time is spent by each individual processes, and if I can present as a histogram, it's great. Because when you're articulating a performance audit engagement to a business stakeholder, right? And if you can keep your reports, your performance audit report, as crisp as possible, it gives clarity. The faster we can reach to the solution of the problem. Like here, I'm looking at is only about how much time I'm spending for the reads, and if there are any wait events which are the bottleneck. That's it. It's the 2 things. Now, why do I, when I'm tracing application outside ClickHouse, why do I need to use even ClickHouse? Good question. I got this question on one of conferences which I was doing a session, very detailed session on troubleshooting with multiple tools. Answer is simple. Do we use everything? No, we don't use every of these things. Like I said in the beginning of the conversation. When I find something seriously going wrong at the native Linux tools, I get into tools, more specialized tracing tools. When I find, yes, it's more and more clearer that the epicenter is going to be database system, then I will use ClickHouse. If my epicenter is ClickHouse, I use the ClickHouse. But then again, I'm not going to use the entire system tables. So when I'm tracing, my objective is very clear. I want to measure the response time. So I want to measure both the wall clock time as well as the CPU time. I want to see that which are those queries which are expensive by response time, and tune relatedly to the system variables of ClickHouse instance, and then collect the data. So I use ClickHouse when I'm using ClickHouse, and when I'm using ClickHouse for my analytics, and if I'm troubleshooting performance, and after clearly understanding that the epicenter of performance bottlenecks ClickHouse, infrastructure, then what my first step is, like I get into this trace log of ClickHouse, and this is a default configuration. This records all the queries which consumes more than 1 second. So I use a system trace log, and I'm seeing there is a latency. Okay, okay. Right. Right. So how does it look like? It looks very direct. It looks like when the date, the time, and what is the latency. Then this leads me to the thread ID and the query ID. From there, I can look at these tables and collect more data. So if you really look at, like, when I get into a conclusion that my performance bottleneck epicenter is ClickHouse, all I look forward to is look at a trace log. From trace log, when I identify the queries which are the bottleneck, I use multiple. I use just 4 system tables provided by ClickHouse. I look at system query log to find out the log of all the queries executed, which is like a start time and end time of the query, and duration, which is the latency, and if there are any errors. And processes to find out, like, both active and idle processes by the throughput, as well on all the system resource usage. And the query thread log, which is like, I want to find out where is the epicenter of this query, what's the source of this query, which is a bottleneck. And this gives me the detailed story of where is the epicenter. Okay, sorry. Okay. So how do I consolidate my effort in ClickHouse performance troubleshooting? I use diagnostic tools so that I can have completely evidence-based performance forensics troubleshooting. I quantify the performance audit exercise, which is like, I compute what is the latency, what is the throughput, what is the impact, what is the cost to the infrastructure of the application at this performance, and definitely what is not performance troubleshooting. So performance troubleshooting is like, definitely you're not solving immediately, right? When you're troubleshooting, the first thing is like, I need to have a document. Rather than using the document, I need to build out a standard governance of the ClickHouse infrastructure, like what was the configuration before and what is after, and in the previous configuration, what is the impact and what's the new configuration look like. So it's not just about troubleshooting and keep it as a black box. That's not the objective. We do record the historical performance data. That's when we use trace log, where always we can purge the data after the careful audit when we don't need the data, and choosing the tools relevant, and pull only the data which is relevant, because more data you pull is like you are adding more cost to the infrastructure. And the big goal is like building systems for performance. That takes me. Thank you so much, guys. Like I took 50 minutes of this talk, and like faster by 5 minutes. Yeah, but then we are hiring. Always passionate to talk to performance engineers, data ops geeks, DevOps guys, SREs. Thank you so much, guys. Like always, like to talk to you. Looking forward to working with one of you. Thank you so much. Now, questions.
Fantastic presentation. Very, very well-rounded. We got a lot of different angles here, and it's quite obvious that you have a lot of knowledge on the topic, as well as databases in general. In the case of ClickHouse, what would you say are common mistakes that folks might make? That, as you mentioned previously, you've worked on a lot of different backgrounds, on a lot of different databases. In terms of the things that make ClickHouse unique, and the sort of don't fall into that trap, or just because you did this on Postgres or perhaps another database doesn't mean it's necessarily going to be the case here. What are things that engineers should be watching out for in that regard?
Very good question. Plan for the growth, right? Imagine you're an engineer who is using a transaction processing database for your application. You get longer time to face the elephant in the room, which is performance. But when you're using ClickHouse, because you're going to use ClickHouse for your analytics, and all your transaction processing data of several years will be pumped in here, and could be the data also coming from some other log stores, because ClickHouse is not just about transaction processing data coming in as a historical data, but also people use ClickHouse for the log analysis, for time series data. So if you're an engineer working on it, plan for the performance from day one. Understand the importance of partitioning, because end of the day, when you are talking about building a database infrastructure which is going to grow really big, which is ClickHouse, look at like how you can efficiently partition so that you're looking about distribution of the disk IO load. The third one is about using the storage engine, right? ClickHouse has multiple storage engines, so you need to look at like how the storage engines work, like, and always never ever disable the logging. When I say logging, it is about your error log, your slow query log. When all these things are enabled, but then you don't go and disable the data, which is very important to troubleshoot. If things goes wrong, you need data. Imagine things goes wrong, you don't have a data, you don't have a trace of your ClickHouse native ClickHouse supported trace mechanism is disabled by any chance. That means that you hit a problem and you don't have any data. You may recover the data, you will do a fresh installation, you'll have a new ClickHouse, you'll come back, but you'll never know that what really went wrong. That is a serious problem for me.
Very good. No, great points there. With that in mind as well, too, looking at as once again, someone who had experience in Twitter and Pinterest, other organizations, when we're thinking about stakeholders, when we're thinking about, there are lots of different database options on the table, how's the process of deciding which one's going to work best? What's the right fit? How does that process go? And what tips might you give to end users that are in similar situations when they have to go through that decision-making process?
Very good question, man. I love to hear this question. Okay, know your data first, right? Don't choose the database systems first. Know your data. What is the purpose of this data? If I am building a system which is transaction oriented, and so my views are very biased to open source free software. So whatever recommendation I do, which will be an open source free software, right? The proprietary software companies are great; they make great things, but then I'm biased to open source software, right? Now, when you're making a transaction processing system, right? Look at like what is a problem you're going to solve here. So MySQL and PostgreSQL and MariaDB all are equally great. Now, what worries me sometimes is about the community support is very important. Two is about how you are going to work on a distributed or more performant replication infrastructure. More complexities are a different problem to solve. So when you're choosing a transaction processing system, choose one which you think that you can manage the support part of it, or you have a reliable support partner in place. Like, for example, I've seen somebody who come to me and say, like, something, we use MongoDB for transaction processing system. MongoDB is a great database, but then are you using MongoDB purely for transaction computing space? Is that for its built? Answer is no. That's a good document store. But if you're looking at a transaction processing system, you're narrowed down into 3 vendors, right? Use MySQL, use MariaDB, use PostgreSQL. You may use storage engines like InnoDB, RocksDB, and again PostgreSQL. So there it ends. The next is like, if I'm building an analytics infra, don't even think about transaction processing system. Don't think about building an analytics platform on MySQL and MariaDB or PostgreSQL and then complain that something, this is not working. It's expected not to work. It's a row-based database system. It's not a column-based database system. If you see in analytics, what we do, I want to find out that how many guys in SF today is running today with their Nike Run accelerator. That is a very column one. It's like you're talking about a product type, the consumer, and just combining 2-3 columns, and then you're aggregating that, right? The structure of the code is different. Structure of the data access pattern is different. That is built a columnar. That's a columnar activity, right? So use a column store. Then you look at like which column store works for you. The third factor is about no matter whichever vendor, whichever platform you're going to choose, keep in mind your compaction factor, your compression capability of a storage engine is very important, because you're going to be the owner of a very large database infra. And two major impacts, right? Bigger database infra is very expensive to handle because your storage cost goes high. Two is about the performance will be impacted, because a query on a database system of 500 terabytes is faster than a query on the same database infrastructure on 2 petabytes. Now, what happens? So you need to look at like how best I can compress my database infrastructure so that my query performance remains good. So these are the quick points, right? And always invest on an observability infra. Like if you have a database infra, do not troubleshoot without evidence. So invest on a very good observability performance monitoring stack, which could be anything, which could be hosted, self-managed, or cloud. That's irrelevant. But then always have one infra so that you hit a problem. Every company who owns a database infrastructure face a performance bottleneck. Not once, not twice, often. Even the large companies face it. Facebook faces it. We have been unhappy with Twitter sometimes. So that's the performance is not a destiny, right? It's a journey. It's a journey where the bottlenecks, the challenges happens during the most busiest day of your life, and that's how it is. So have the evidence so that you can troubleshoot it intuitively.
Very good points. And with that, we're talking about performance. We're talking about anything really in any database. If we're looking at pluses and minuses, we can talk about scalability, like you said, on some of those key dates. Classic examples being Black Friday, Cyber Monday, etc. We're talking about these trade-offs. What are the typical things to say? Oh, well, this is going to be high performance. Well, does that also mean high cost? Does that mean high maintenance? Does it become a problem of the operators who are going to be working with it? Do we have a team that's qualified enough to get to that point? How do you gauge the extent to which a team really is ready to be, running and operating something with such high performance?
Oh, fantastic. Trust me, this is one of the best questions which I answered in last 2 months. Right, this is the best question. So let me answer this question. This is a very tricky question also. Actually, why? When you ask me about what it really takes, and from effort and cost and the time perspective on building a high performant optimal database infrastructure. It's a combination of one about your process, right? Who or how much visibility you have on your database infrastructure. Do you look at your database infrastructure operations only when there is a performance bottleneck? If that is a strategy you're going forward to, then you have good days or like great days because there is no work. Bad days are the worst days because you don't have any access to the knowledge. You're just like jumping to a deep sea with no lifeguard. Right. The next part of the story is like you're methodical. Like you're like, hey, something. Every Tuesday, I need to take a report of last 5 days thread latency report. Like which were those top 10 threads, the processes which consumed my resources, or like by expensive, by latency, by response time. So when you are methodical, this is like how the military operations work. They have daily military drill, even though there's war is not happening every day. There may be a war happening once in 5 years or 10 years or never. But then the drill is to make sure that they prepare for that. So same is like when I'm building a system in a data accelerated world today, it's good to have tools of success, which is definitely how I record both good and bad story of my data infrastructure. So that one, there's a great learning experience. Two is like I troubleshoot proactively. The business of customer should not be the guy who calls and says, something your database infrastructure performance is terrible. No, that is something which is most painful thing for a data infra owner. I personally take it. But rather, if it is like, hey, something, I have a time series data. I know that how the performance of the systems are changing with the patterns in the SQL have changed over the last 5 days, 10 days. That means that I need to go relook at my indexing methods. I need to look at my partition pruning methods, or maybe I need to add more number of clusters so that I'm distributing horizontally the traffic. So it's about either you be always ready for the battle, or you fight the battle when it comes. So that's a way of looking at it.
Very, very good. And like you said, it's not something easy to answer. There's no one answer to that. It's not singular. I just think it's something that has to be considered, and we see the same thing in our community when we talk about running data on Kubernetes, running stateful workloads on Kubernetes. Is it a financial challenge because you need to build an operator? Also a talent challenge because you have engineers with enough experience that they can do that? Do you have, is your use case matching up with this? There are different things that have to be included. And like I said, there's no magic singular answer for that. But I think it's just an important thing to keep in mind. The interesting thing with this to me as well is that frequently, this is live stream number 118. As much as we're always talking about technology, there are these human management questions that we have to be thinking about at an organizational level regarding, like you said, are we ready to be, are we readily prepared to deal with the mistakes when they come, or the issues, the problems, because they will come? And, how is that built into our roadmap? Is our staff accustomed to dealing with these kind of, fires in production, things of that nature? I think these are really, really good things for everybody to be thinking about. Who's in my team? How do we look at this kind of stuff? What's our level of experience and comfort? Very, very good points being mentioned there. Shiv, can I get you to stop sharing your screen really quickly so I can share mine before we wrap up? Perfect. As is a custom in our community, I'm going to share my screen as we have a very wonderful summary of the things that were being shared. So while we were talking, we have our amazing artist, Angel, who's in the background, creating a visual depiction of the various topics that were mentioned. There's a lot of very practical advice, and gratefully, luckily, we have the slides. So if you arrived a little bit late, they will be on our SlideShare account. But this is the visual summary that Angel was able to put together in the background while this was going on. Shiv, this is fantastic. I think if there was any doubt about your expertise when it comes to databases, that is gone. Very nice to be able to touch on the first BPF and then eBPF paradigm, because we had one live stream about that a few months ago, but very nice to touch on that because that is a very hot topic that we're seeing in our community as well as in the CNCF more broadly. So that's something people can keep their eyes open for. I left your Twitter link in the YouTube comments. So folks want to check you out there, they can do so. Also LinkedIn, our Slack channel, very easy to get in touch, and very nice to have you with us today. I really hope that you submit a proposal for KubeCon so we can see you there in Spain in May. And thanks folks for joining so much. You got the rest of the info for our upcoming live streams. Shiv, thank you so much for your time today.
Thank you so much, man. Thank you so much for having me on this. Always looking forward to these great initiatives which you do with a very lean team. Like it's very impressive. Like I mean, this is from the team, from the heart. It is like thank you so much, man, for taking all this effort. I'm sure there's a lot of day and night of effort you're doing for this. Thank you so much, man. Like a lot of respect for you.
Thank you very much. Absolute pleasure being able to interact with folks like yourself who are very, very knowledgeable about these things. And this is all about sharing that knowledge and helping people grow. So anyway, thank you very much. Take care. Have a good one, everybody. Bye-bye.